Okay, today we are doing a deep dive into some of the foundational tech that really keeps the modern world running.
The invisible stuff.
Exactly. We're looking at a high-reliability control system, the Thor Broadcast F-16CC-B-TxRx kit.
It's a mouthful.
It is, but we're going to unpack what 16 bidirectional contact closures, or TTL over fiber, actually means, and, why this is so critical for our infrastructure.
So to start, let's just talk about the most basic command you can imagine, an on-off switch.
Okay.
A contact closure is, well, it's essentially just that. It's an elegant, high-reliability switch. When a relay closes on one end, the transmitter side.
The TX side.
Right, the TX. This device makes sure that exact same closure happens instantly on the other end, the receiver, even if it's miles away. It's like a remote electrical messenger.
That makes perfect sense for, a single switch.
Mm-hmm.
But this thing handles 16 channels, and it's bidirectional. So if we're just talking about a simple switch, why all the complexity? I mean, are these systems really so intricate that they need 16 separate inputs for just one junction?
Oh, they absolutely are. Think about, say, a traffic control system.
Right.
You've got signals for activation, for status, for safety overrides, error reporting.
Yeah.
And a lot of that is flowing in both directions at the same time.
Yeah.
And what's more, this kit doesn't just support those mechanical switches, the dry contact closures. It also handles high-speed 5 VPP TTL signals.
And what's the key difference with TTL?
Speed. TTL means this device can handle modern digital logic. We're talking about control events that happen way, way too fast for a standard mechanical relay to even register.
Okay, so we've nailed down the what. Now let's jump to the why. Why are we using fiber for what seems like a simple job? I mean, copper is cheaper, it's easier to work with.
And that's the core engineering hurdle right there. If you run, say, 20 kilometers of copper wire,
You're going to have problems.
you're going to have huge problems with electrical noise. Not just static, but phantom triggers caused by induced currents, EMI, RFI.
Electromagnetic and radio frequency interference.
Exactly. And crucially, fiber eliminates ground loops. Those are almost impossible to troubleshoot. So fiber isn't just cleaner, it's a necessary choice for this kind of long-haul control.
So the trade-off is giving up the simplicity of copper for the absolute guarantee of reliability and distance?
That's it.
And speaking of distance, the range here is impressive. Up to 20 kilometers on single-mode fiber.
Which is pretty incredible. And even on multi-mode, you're still getting 3,000 feet.
Not bad at all.
And the design itself, it's engineered for simplicity where it counts. It supports point-to-point, but also daisy-chain setups for more complex routes.
And it's plug and play.
That's a huge advantage in the field. No optical adjustments needed. It eliminates a huge point of failure during installation.
So bringing this back down to earth, what does this actually mean for you and me on the street? These reliable, silent messengers are basically running everything from highway control systems to, facility access?
Fire safety, building automation, environmental controls, you name it. When you look at those applications, reliability isn't just a preference, it becomes a mandate.
Which raises the question, right? How reliable is it really?
Well, they use a metric for this. The mean time between failures, or MTBF, for this device, it's rated at over 100,000 hours.
100,000 hours? What does that actually translate to?
You're looking at continuous operation for over 11 years, and that's under tough conditions. We're talking from a freezing -20 Celsius up to a blistering 75 degrees.
Wow.
That number just emphasizes the expectation here. These systems must operate flawlessly. A single failure in a major traffic system could, instantly stall out an entire city.
So this Thor device is basically a robust, long-distance electrical messenger that allows our critical systems to work, all based on simple binary perfection.
Exactly. And here's something to think about as you move through your day. Consider the hidden complexity that's required just to make sure a simple on signal is sent perfectly, instantaneously, across huge distances without a single error.
Right.
Think about how fast a modern city would just halt. If its essential communications, its traffic lights, its fire systems failed to talk to each other reliably. It really reveals the critical and often totally overlooked importance of a device just like this one.